We'll end this section in this video with just one pretty simple example. Draw a triangle ABP where PA is equal to PB. So you have two sides of the triangle that are equal. So it's going to be an isosceles triangle. So I'm going to start like this. Let's do A, P, B. Connect this. A, P, B. So we have our isosceles triangle. Label M as the midpoint of AB. So something like that. That'll be M. Prove that M is equidistant from the ray PA and PB. So just for the fun of it, I'll extend those out a little bit. PA is that ray, PB is that ray. It wasn't necessary, but went ahead and did it. So, do you remember what the distance is between a point and a line, or a line segment, or a point and a ray? It's the perpendicular distance. So let's prove that. And here comes the proof. And notice how it's starting off. Let's see. What are we trying to prove? We're trying to prove that this, I don't like even to draw it yet, but I put a notch there and a notch there. We're trying to prove that AM is equal to MB. Oh, no, I'm sorry. I stated that wrong. M is the midpoint. This is given to us already. By M being the midpoint, we know that this length that AM is equal to MB. What we're going to try to prove is that M is equidistant from, that means the same distance from these two rays. So when we do the perpendicular distance here, draw that line segment and draw this line segment, those distances are equal to each other. So drop a perpendicular MC to the ray PA. Okay, so MC means I've got to draw a perpendicular like this and call that point C right there. Since it's perpendicular, we know we've got right angles there and there. And drop a perpendicular MD, which means we need to create the point D to the ray PB. So go perpendicular to that, and we will call that point D. And again, we have right angles. Okay, as mentioned already, since M is the midpoint of AB, we know that AM, that distance, is equal to MB. All right, since PA is equal to PB, PA is PB because those were isosceles triangles. We know that, what does that tell us? Angle A, I'll say the measure of angle A, is equal to the measure of angle B. That is congruent to that. Those were isosceles triangles. All right, by the HA theorem, the hypotenuse angle theorem, we have right angle here, an angle here congruent to this angle, and we have and that's it. We have the 90-degree angle, right, because they're right angles. We have another angle. We have the HA theorem that MAC triangle is congruent to triangle MBD. Okay, and therefore the side MC, which we'll put two notches through, is equal to the side MD, equal in length. And that's what we were trying to prove, and that's true by the corresponding parts of congruent figures are congruent. And that's the end of this section.